streaming again. Welcome back. We're going on the YouTube sphere and the Twitchernet. That's the Scanlime-in-Progress channel on YouTube and twitch.tv/scanlime. And live.diode.zone/scanlime as well. Getting the bits direct from the cow, or that came out wrong. It's like the, you know, the fresh product, right? Not that we have any milk production here. Anyway, we have this weird NAS device that's been misbehaving, and this stream is going to be just a continuation of my efforts to try to unbrick it a little bit. One thing that came up between yesterday's stream and today's stream, I actually got an email from the tech support, which I had been in contact with. They weren't really going to help because this device is out of warranty. Even though it seemed like it was a firmware update that bricked it, I was hoping to get some information about how to recover it, or maybe, you know, something. But yeah, that was kind of a dead end. But actually, yeah, I guess someone else looked at the tech support case or something, and I got another email from someone else at tech support this morning, and they were offering to actually just repair it. So that's pretty cool. We've got that option now. One reason why we might not want to do that is, well, so I don't actually know if they would still repair this after I've already been in here tinkering with it. A lot of repair folks wouldn't want that, and a lot of manufacturers wouldn't want that, for good reason, because a lot of folks tinkering with boards tend to make the problem worse. So yeah, I mean, it's a nice offer. I don't know if the offer is actually still real, considering what we've already been doing to this device, but you know, there's that. I'm still kind of inclined, though, just to continue and see what we can find out about this device. Partly because I don't really want to wait on a repair if I can avoid it. If I can fix this thing myself, which it seems like we might be close to at least being able to get it to boot, maybe. If we can get it to that point, then I can just go ahead and use this thing enough to move the data from this drive array to a different drive array, and that'll be cool. If not, you know, worst case, I have to restore an offsite backup, which maybe is a little bit older than the current contents, but probably doesn't involve like losing any data that I care about. So, you know, we have a decent backup strategy, which is literally a backup, which is what you should have. I never really trust any storage array, no matter how much disk redundancy, right? Because there's all sorts of other stuff that can go wrong. Anyway. Couldn't quite tell, but it sounded like the audio was clipping for a sec. Maybe that was my imagination. Anyway, Tuco is in a really adorable spot. Let's see if we can actually get the camera on him. This is a nice view. You can kind of see my messy shop that I'm still in the middle of organizing haphazardly. You can see the more organized corner that I'm actually streaming from. Yeah. Oh, Tuco, are you coming down? All right. Oh, I was like, the computer vision is doing a bad job, but actually the computer vision is not running. I missed a step in setting up today's stream. Oops. Booting up the computer vision. Oh, Tuke's back in his favorite spot there. Do we have the computer vision? We do. It hasn't quite locked onto him. Now it has. That's nice. Yeah, the workshop organization is definitely a never-ending task. It stresses me out in its current state, and it's nice having at least small parts of it that feel organized enough to use. Let's hang out here for a bit. Yeah. All right. So I'm not gonna give like a full recap on this, but just for the basics about what's going on here, this is a Drobo, which is a consumer NAS, network attached storage device. Most of it is over here in pieces on top of what might be its replacement, this 2U Supermicro box there. So yeah, you can see the pieces. Oh, we should really be in autofocus here. So it takes 5 SATA disks. I had it loaded up with 6 terabyte drives, which all seem to be fine. There's the Tuco camera. It still needs some work on the LEDs. I've been neglecting my Tuco Flyer work too. There's more computers. So yeah, I've got the circuit boards down here. This is the back plane for all the disks, and I've been trying it with and without this, but lately I've been working more without it because, as far as I can tell, I think this thing would boot without the back plane attached. But yeah, if we get in a situation where the system on chip is booting and then not behaving as we expect, then it's possible we have to attach the back plane. But actually, now that I think about it, the back plane is probably mostly only talking to the power management microcontroller. Anyway, getting a little ahead of myself. So the architecture here. This is an NAS. It's basically a special purpose computer. It's a storage appliance. Instead of using like an Intel processor, they use an ARM processor because it's lower power and it's cheaper. They're also doing something kind of weird where it's actually running 2 operating systems. So it's a 4-core processor, if I remember right, and I think they're running VxWorks on 1 of the cores and Linux on 3 of the cores. And they're using Linux as an easy off-the-shelf way of running like a web server and a Samba server and just like all the kind of consumer off-the-shelf protocol stuff that you would expect, because they don't want to have to write all of that stuff for a more custom operating system. And then the VxWorks core seems to be something that they share between a wide range of products. So devices that would be directly attached to like SCSI or USB would still have that same VxWorks image or something close to it, probably. But in this case, that's providing an emulated SCSI device, which the Linux side of the whole system would then mount. And it's a really strange architecture where the custom volume management layer that they've written in VxWorks, it's configured to provide this big abstract 64 terabyte block device that's actually backed by whatever real amount of storage you have, and then they've probably got some kind of like copy on write and like versioning layer behind that, and probably got some kind of asynchronous way of collecting garbage and figuring out which blocks are no longer in use by the file system and returning them to a pool. We were finding evidence of those sorts of procedures just looking at the strings in their firmware update, but it also just seems like that's the kind of architecture they would need in order to provide a big kind of abstract block device like that to Linux. But one thing that kind of gives me pause there is like they have a lot of very file system specific code in there too. Like they have to understand the partition table and the file system type that's on that block device in order to figure out where the empty space is. So it seems kind of error prone, and one of the problems I've had with this unit in the past is when the file system has been or when the disk array has been close to full, it is very unstable, and it has been prone to just like crashing and then like losing the entire disk array in that state. And Also related to that kind of space reclamation process is whenever I delete a large file, after that, for a long time, the unit is really, really slow because it's doing disk I/O in order to reclaim that space. So yeah, the whole architecture is not amazing, and after having used one of this for a while and tried to make use of it as well as I can, I've gotten a lot of use out of it, and it's been, it was probably better for my needs when I first bought it many, many years ago, because then I was more concerned about having something small and fairly self-contained and that I didn't really need to mess with, because I was just so tired of being my own IT department at that point. But yeah, the downside of a device that's designed to be kind of easy and self-contained is that when it inevitably does go wrong, you're completely at the mercy of either a bunch of your own reverse engineering or tech support deciding that they'll allow you to send the device back. So yeah, that's kind of frustrating. But anyway, I'm taking an attempt at getting this device to boot so that I can at least get the data off of my array instead of having to restore my slightly out of date and somewhat far away offsite backup. Not that the backup is that big of a deal, but it would be nice if I can get the data off of this. So I'm making an attempt. And after looking at what's going on here, in addition to those two operating systems, the Linux side and the VxWorks side, there's also an embedded system here. So that's this little processor that we've had the microscope on. It's a TI MSP430, which is a really big family of 16-bit micros that you'll find in all sorts of different devices. I'm personally not as familiar with these. I've mostly found myself working on stuff that has like a PIC or an AVR, but a lot of people find these extremely familiar and common. And this is a pretty low-end part from that range. I think it tops out at 16 megahertz. It has some A to D converters and some timers and basic microcontroller kind of stuff. I think this is a 38 pin package. Actually printed out the pinout. It's easier to mark it up this way without having to juggle windows on the computer. Yeah, one of the MSP430's selling points is that it can be really, really low power. And they're also pretty inexpensive, but not as much so as like what you could probably buy in China nowadays. But for like a Texas Instrument part, they're pretty inexpensive. So I've been getting some hints about what this microcontroller does from two sides. One is just looking at what's physically attached to it, but that's a little hit or miss to figure out what's actually going there because this is just a complicated multi-layer board, and so usually tracing things out, the traces just immediately go to an inner layer and you lose them. So I kind of have to search, I kind of have to get some idea of where the traces might go based on where the vias are located and kind of context for what else is going on nearby, and then make a bunch of guesses and check them using the multimeter, that kind of thing. So from that, though, I've already figured out a handful of things. This seems to be in charge of at least a couple of DC to DC converters, powering them on. It seems to be connected directly to the power button, the power LED. The symptom that we were getting. So I didn't really explain the full backstory for how this problem happened, but it was this seems to be the fallout from a failed firmware update. It's possible it was also just an unrelated hardware problem that wasn't noticed until shortly after the firmware update because the device just hadn't been rebooted in a while. So that's certainly a possibility. But most of the signs here point to this being the result of a failed firmware update that left this MSP430 in a state where it's not booting. So what happens is as soon as you apply the external power, instead of having a normal functional soft power control, after a short delay of like 100 milliseconds or so, the power LED briefly lights, I forget exactly how long, but it's on the order of milliseconds. Very, very short power LED flash, and then it reboots again. So it's stuck in that kind of reboot cycle. This microcontroller is getting stable 3.3 volt power, and it doesn't seem like the device was subject to, unless this was, like I said, some kind of existing failure that we just didn't notice until rebooting it a couple times. It doesn't seem like it would be a hardware failure. One hint that we did get from tech support was that it might have been the internal battery dead. I got this kind of bizarre message from them claiming that No, it wasn't the firmware update. It was actually that the internal power source is dead, which is bad for multiple reasons. Like, why would you design something to fail to boot as soon as the internal battery dies? Like, even like PC BIOSes and stuff, they'll still try to boot. They'll just tell you that they're using default settings, right? So that didn't make a lot of sense, but I did go back and try attaching an external power supply and a appropriate resistor to simulate the temperature sensor, and it didn't make any difference. But I've been doing that in all my testing subsequently, just to simulate having a working battery and temperature sensor there. So yeah, no luck with that. It still looks like the MSP430 is just not booting. So I spent most of yesterday's stream just trying to reflash the MSP430. And like I said, this is not an architecture I'm super familiar with, so I was having to kind of learn as I went. I'm familiar with this serial bootloader, the BSL or bootstrap loader, that most of these MSP430s have. I'm also familiar that with the fact that they support JTAG and some kind of serial version of JTAG. And so I haven't tried the JTAG or serial JTAG. It looks like those might involve soldering a bunch of wires, and I suspect that they would be disabled, because if they weren't disabled, they would probably have a connector for that. I haven't found anything that looks like a connector for the JTAG on this part. What I did find was a connector that exposed the reset pin and the test pin, both of which are needed for entering the bootstrap loader mode over the serial port. I should look into which pins the serial variant of JTAG they support would use, because like if that's something that you can do over just the reset and test pins, then that's worth looking into. I also don't really have any TI development tools handy, so I can't just plug in like an official TI programmer into this thing. So we were making do using this really hacky Raspberry Pi hacked up Python script on the last stream, which was kind of bad, and I was running into problems with that repeatedly. But I got to the point where I was pretty sure that that script was working right, but I was still getting unexpected responses from the bootloader. So the bootloader would synchronize correctly, but then tell me it was failing to acknowledge the command, which is different than being locked and different from just not communicating at all. It was detecting the framing of the packets correctly. So after the right number of bytes, it was giving me a failure to acknowledge, and it was giving me a successful acknowledge after the next synchronized byte. So at a byte framing level, it looks correct. I was also seeing some other weird side effects, like it looked like it might have been transmitting at a different baud rate during some earlier experiments where I was just giving it garbage data. So that implies that perhaps, I mean, I wasn't giving it garbage data on purpose, but like the BSL code I was using was broken in an unrelated way. But as a side effect of that, that caused me to notice that under these circumstances where I was giving it kind of garbagey data, sometimes it responded in a weird baud rate. So that tells me that maybe at least I should be able to tell it to change baud rates. But even sending that command, I couldn't really getting any response. One theory is that they modified the way CRCs are calculated. I've never heard of anyone doing that on an MSP430 bootloader, but what do I know about MSP430s? So that might be the case. We could try brute forcing the CRC. I started down that road a little bit on the last stream, but I just really don't have the enthusiasm for that right now. It just does not seem very likely to work and seems like a lot of annoyance. So there are a couple of other options. So where we're at right now, we have this MSP430, which is responsible for turning on the system. It's not getting to that point yet. We could try either replacing it with a fresh MSP430 of the same model that we know we can get into the bootloader of. And then I've got a binary image for the application that's supposed to run on here from the firmware updater. If you look in the VxWorks ELF file, there's a bunch of ASCII hex S records. So it's a standard format that you would usually store microcontroller firmware in. And then if you look at where those are referenced, it's got some code that is sending those over the serial port to the bootloader on here for self-programming, or to the application on here for self-programming. So that didn't give me any hints about how the bootstrap loader is normally used, if at all, since they seem to be just doing self-programming for normal upgrades. But it does give me this image, which doesn't have the bootloader portion. Like, it doesn't have the actual reset vector of the processor. It has like a different vector table that the bootloader transfers control into. But it does have all these hints about how the application works and like what the rest of the IOs might be used for, that kind of thing. So we can use that maybe, either for reference or just to try to program it back on here. If we did put a fresh MSP430 on here, program it with that application image, we'd still need to bypass that like empty spot where the bootloader should go. So I'd probably just need to write like some linking jumps from the old vector table to the new vector table. I'm noticing though that the MSP430 firmware seems to be position independent code. So if that's the case, maybe I just move it up a little bit and splat it on top of where the bootloader usually goes and it works, but it seems safer to add jumps. Anyway, that's all stuff to do once I have some fresh MSP430s and some dev tools, which I ordered from DigiKey this morning, but that'll take a little while to get here. Maybe in the meantime, we just try to power on the system on chip bypassing the MSP430, and then just see if we can make some progress at like getting data off the disks, you know. So one challenge there is I know nothing about what the power tree for this board looks like or how you safely power on the system on chip. So to figure that out, I either have to kind of like guess and check with the multimeter, or by following what little I can see about the way the traces are laid out. Or I can look at what this application firmware is trying to do. It's a little bit hard to follow because it's position-independent code, and my ancient version of IDA does not really handle MSP430 position-independent code very well. We could try a different tool. There is an MSP430 plugin for Binary Ninja, but I didn't see any indication that it supported position-independent code at all. I haven't looked at Radare 2. We could look at that and see what its MSP430 support is like. But yeah, so, you know, it's a weird little project. Like I said, I have other ways I could be doing this. I could just give up on those disks, restore everything from offsite backup. I might have lost a tiny bit of data, but probably not much I care about. And then, you know, at that point, I can finish repairing this if I want to, or I can send it to tech support and let them deal with it, or I can junk it. I don't know. Given that I've got the repair offer, you know, I might as well send it. But yeah, it is interesting to try to fix this ourselves, and the practical reason to try that is that whereas the data itself is recoverable, I have offsite backups, and I don't really care about this chassis that much. I don't think it's very reliable or a good product, and I'd like to just use this as a good opportunity to switch to a better NAS chassis anyway, like the Loud 2U I've got sitting on the floor. But yeah, one thing I am actually blocked on is the disks I had in this enclosure are actually important to me because they're the only thing I have that's large enough to store all this data that I need to work with. I also figured I should get some more disks for the NAS, so I do have some more disks on the way. So once those arrive, I'll have yet another way of solving this problem. But right now, when I need a place to put this data, and I don't have spare MSP430s, and I don't have spare disks, and I don't have a spare Drobo, right now, the fastest solution to get my data off this thing might actually be to try to, you know, bypass this MSP430 and get the system on chip to boot. So there's that. So he's asking if there's a power management IC that takes care of sequencing. Yeah, there's a lot going on. I mean, there's multiple DC-DC converters on here. One of the DC-DC converters seemed to be programmable in some way. Like, I don't know if they were just using fancy words to refer to a serial interface or if it actually has non-volatile memory in it. But yeah, there's a lot to look into. And different approaches there. You know, one approach might be to just kind of do this entirely from the firmware side and just try to either simulate what the firmware would normally do, or to replace the MSP430 or something like that. My inclination is to just spend a little bit of time just kind of probing around with the multimeter, trying to get a feel for the power tree. I've also already gotten a few hints from the firmware, which we could look into. But gosh, you know, before I started this stream, I was thinking that I was fully caffeinated and ready to go. But after talking and giving that recap, I think I might need a beverage. So maybe I will go make some coffee before I really dig into this. But I'm going to leave you with the Tuco cam while I do that, because Tuco is looking really good right now. But maybe with less glare. Gosh, it really annoys me how long this Xbox controller takes to boot. Oh, cool. Ben confirms that that little port with the reset and test could actually be a serial JTAG. Well, yeah, that would be easy to look into once my TI dev tool arrives in the mail. But maybe we can find a way to do that with OpenOCD on a Raspberry Pi. I can look into that if you feel like jumping ahead and giving me some links. That might be cool too, but either way, I'm going to go take a coffee break. Is that what you call it when you make the coffee? I was going to drink it here, but I've got to go over there to make some coffee. Oh yeah, this will be great in a couple minutes. Let's see, where are we? Not quite sure what you mean, Zoe, asking if the MSP is programmed from the system on chip over serial. That's something that happened in the past. Like, the failed firmware update that bricked this thing already happened. I can't easily reproduce that right now because I can't power on the system on chip. So I can look at the code and see what it would be doing in that circumstance, but I can't just run that right now. Jason wants some coffee. Yeah, I wish I could send any of you who wants some coffee, some coffee over HTTP or something. I did get the power supply camera working. I needed to pick a camera that has Windows drivers, and I also needed to have enough USB isochronous bandwidth free. Oh, that's an interesting question, whether the microcontroller might be sending some error message as it's resetting. I did look. I think I checked all the microcontroller pins to see if there were any interesting signals, and I probably would have noticed a serial message, but I might have missed something. I would be really surprised if it's getting around to actually sending a serial message, though. Like this, the symptoms here look like the micro is crashing in the kind of way that it would crash if like half of its memory were erased. Oh yeah, this was another experiment I tried. I was just kind of curious what it would take to run the VxWorks image in an emulation. So QEMU actually provides like a generic ARM system target, which of course won't emulate any of the MMIO or anything that we're doing. But I was just kind of curious, like how many steps away from actually a useful emulation we are. And we do get to the point of basically getting to the first MMIO access. So where was it? I think right around, yeah, right around here. There's some kind of MMIO store. So like, you know, we get a processor emulation basically for free because this is a nice common ARM processor, right? But we would still need to emulate a lot of features of the processor in order to get this binary up to the point where it's like able to communicate with a PCI SATA controller, you know? So like even if the disk device is something we don't have to write a model for ourselves, getting the machine to boot is probably a significant hurdle. And as far as I can tell, the kernel and the application aren't especially easy to separate. It's just a monolithic binary. So yeah, I was looking a little bit into emulating the VxWorks image, but I don't think that's going to be worth the time really soon. That might just be something to think about longer term, maybe. These are the files that are on the USB storage drive on the Drobo. So I did mention a little bit about the non-volatile storage earlier. It's got a lot of non-volatile storage. It's got a bunch of separate serial EEPROMs, a lot of which are probably configuration or firmware for peripheral chips like the SATA controllers. It's also got this, well, and then it's got the MSP430 with its firmware, of course, that we were talking about. And then it's also got two separate flash memories. It has parallel flash, which, as far as I can tell, is probably programmed with U-boot, but we haven't verified that. And then it has this USB disk on module, which is just a circuit board with a USB header on it that has a gigabyte of flash, and that's what these files are sitting on. So this is read-write. It has log files, but it also has updatable firmware binaries. So those LXKI, LXFS, VXIM, those are the same names that you would see inside a firmware update bundle. And then it seems to have a couple of different versions of those files too. So for example, these VxWorks files are old. I think VXIM is the same purpose, but is now, like maybe actually VXIM and RTPI used to be this. Like I don't know if that's what's going on here. What is even RTPI? That's another ELF. Actually, that's interesting, because I was assuming the VxWorks kernel and application are a monolithic binary. It's possible it's a little more complicated than that. And that's interesting too, so this is a prefix that I would find inside the firmware image for the MSP430, and I was using the copy of it that I found in here, but I don't think I was aware that there was also a copy of that inside RTPI. And this looks pretty similar, like maybe the same application compiled with different options. RTP image. We've seen this term RTP come up in many places. The entire firmware package is separated into a version with RTP and a version without RTP. I don't know what it means in this context. I'm aware of other meanings for RTP, but I'm not aware of a meaning for RTP that makes sense given what we've seen so far. So yeah, this seems like basically the same thing that we were seeing elsewhere, but with more stuff in it. It's larger. So if we were to compare the image with RTP and the regular image, we'd probably see what the RTP part means. In fact, what if we just look at the strings, because that'll tell us whether the firmware is the same at least, and might also give us some more info. No idea how noisy this is going to be. Not a lot of actual matches here. I think I need to get diff to try harder to line things up. No idea how long this is going to take. All right. This is not useful. Oh, maybe they aren't the same then. So RTPI, maybe that's a loadable binary that the kernel loads afterwards. Yeah, those S11s were actually false positives. These are just part of a mangled C++ name. And that looks like the same firmware I've already been looking at. Oh well. Yeah, and so that firmware so crowded. I think my other video grabber is hung. Let's reset this video grabber. That's better. I couldn't tell if the recording was frozen or just the preview, but either way. Okay, so here's the path I've taken to get here. So this is just an old version of IDA, which is an interactive disassembler with a copy of this hex S record loaded into it. So it's not the entire firmware, but it's the application image portion of it. And as I keep saying, I'm an MSP430 newbie, so I don't really know what I'm doing here. But I wanted to find out where the I/O for this DC-DC converter is touched. So as I keep saying, I don't know much about the power tree on this board yet, so I don't know what things I have to turn on in what order to actually get the system on chip to be powered up safely. But I do know there's this one big DC-DC converter that seems like it would be necessary that isn't turned on, and I just kind of got lucky and traced its enable pin to one of the I/Os on this chip. So that so that was over here, pin 38, and that's labeled port 1, bit 7. So port 1, I couldn't find like a PDF document from TI with register addresses, but if you look around and find the right header files, then you can find the addresses there. So this is MSP430F2232.h, which is the C language header file definition for all of these registers. And it's just not a bad cheat sheet for addresses if you need one. So that was port 1. If we want to find out where the firmware is turning this on, we could be looking for setting a bit on port 1 out. So port 1 out, the address is way down here at OX21. And so I already labeled this P1 out. If I look at cross-references, there are only a few places where this is used. So here's something where we're reading port 1. This looks like some initialization, maybe. Actually, this is weird. This is just, these look like they would be no ops, but maybe there's some kind of special read, modify, write behavior that has. So that's probably some kind of initialization, but we could put a pin in it. Here's something for turning off all the IOs, maybe for like a power down. But then here's a routine, which I've already named this, so it's a little bit of a giveaway, DC-DC power control. But this is one subroutine that has a code path that sets or clears this exact pin, so P1.7. So that seems pretty great. Let's go there. And then graph is kind of handy. And again, I don't know much about MSP430 at all, so based on context, I'm guessing R12 is probably a parameter for this function, and we're like maybe R12 and R13 are parameters, and these are maybe just booleans indicating power state for two different DC-DC converters. So if parameter R12 is set, it sets the bit on 1.7. If it's clear, it clears the bit on 1.7. And then based on this context, we can tell that, well, we know this is a DC-DC converter enable pin. Hey, I wonder if this is also a DC-DC converter enable pin. It just seems to set this right afterwards, but based on a different flag. So they aren't necessarily used for the same purpose, but they're something that you'd want to set at the same time. And this is on pin, port 4, pin 4, 4.4. So let's see where that goes. So yeah, I labeled that down here. Pin 4 or port 4, pin 4 over there on pin 21. So that's some kind of switch. Let's see where that goes. Let's have an anti-static strap, why not? Just an interesting suggestion. Kristen in chat suggests that if I don't want it to try charging the LiPo, I could just turn up the voltage. Yeah, sure. I wasn't really concerned about that, but sure, we could do that. My hunch is that the firmware is not getting to the point where it actually gets to read the battery voltage yet, but we don't really know that for sure yet. Okay, so first I'm just going to see where it goes from visual inspection. I don't really expect this to work. Assuming this doesn't, I think maybe the next step would be to solder a wire to that pin, because we'll need one anyway, and then I can use that to make it easier to probe where the other end of this trace is. I think that's it. Sure seems like that should be it. Maybe I'm just not getting a good connection. maybe it's this left one. Yeah, because maybe this goes over here. Yeah, okay. Right up here under this bundle of traces. Okay. This board's getting harder to move with all this stuff attached to it. I get used to looking at this thing under the microscope, and then I look at it in person, and I'm like, where the heck was I working? Yep, it just goes right to an internal layer. I have no idea where that goes. There's nothing but a couple of high-speed traces and some grounds on the bottom, so it just goes off somewhere. Yeah, well, let's solder a wire to that, and then I can start probing around all the DC-DCs I can find to see if it controls any of these others. Gosh, these 40-gauge wires are just crazy small. Alright, power off. Get the soldering iron out. To leave the soldering iron out because my cat can get into it, you know. So yeah, another thing we could try is that single wire debug protocol for the MSP430. I don't know anything about it, but if OpenOCD can do it over a Raspberry Pi's GPIOs, we could try it right away. Otherwise, that'll have to wait until after I have a TI flash emulation tool or whatever. Yeah, I don't think I like the 40 gauge wire. It's so small it's actually hard to see. I mean, it looks great under the microscope, but when I'm not using the microscope, I can just barely see the 40 gauge wire. Oh, yeah, I should just switch wire. This is no good. My wire is disorganized, but I need to find this. So yeah, that is 40 gauge wire, which is not useful for this kind of rework. It's just too small. Oh yeah, I should try other times. Like, I don't have really a rigid schedule, obviously. Yeah, and I mean, they're mostly just whenever I can do them. Like, I just tend to have a bunch of stuff that I need to do before I can actually stream, and so, like, it's hard to get them going, like, really early unless I'm doing something that's pretty much already ready to go. Oh. 32. This is better. Disorganized box of stuff that I'm trying to keep Tuco out of. Oh, this spool is really yellowed. The sunlight here was not kind to it. Okay, yeah, I'm going to redo the one that I just put on because it's so bad. It's just so little. Can't deal with it. But I'm actually going to put on two at the same time because I want to take both pin 38 and pin 21. Oh, and there's a question about stripping the wire. There are a lot of different methods. My usual is to just have a blob of solder on the end of the iron that I use to heat up and burn off the flux, or not the flux, the lacquer coating. And you need a decent amount of solder and flux just to conduct all the heat in there. It takes a little bit of practice, and it works better on some types of wire than others. That's what I was about to do. I guess I could be getting that on camera, but I don't really want to set that up for just this shot right now. once you burn off the insulation on the very, very tip of the wire, then that will wet with solder and the whole process kind of creeps back along the lacquer. I guess I can show you preparing this end of the wire more easily. Just trim both these to length. So I've got these two wires that are soldered on the other end to my temporary header. And just keep them a little shorter. So that's just a piece of wire. And now it's tinned and stripped. That's how I've been doing those. I've been doing this a lot. It's just a lot faster to not get it on film, but I should get a couple of these on film, I guess. I'm even recording it. Isn't that great? I remember to start the recorder. Okay. was so thin I didn't actually have a good grab with my tweezers. It's better. This stuff is thin enough I worry about my cat like accidentally eating it. I like 32 gauge wire. I think it's my favorite gauge. That thinner stuff is 40, which is just kind of nuts, in my opinion. I don't think I quite had enough solder on the tip there. Thought I had enough solder. That's too much solder. Right. Okay, so control, experiment. Let's see if we've got a good connection to that known DC to DC converter up here. I think this would be this pin. I thought the enable was one of these. Oh, maybe this doesn't go where I thought it went. I don't remember which of these it was the enable. I thought it was pin 1 or 2. notes from earlier had pin 38 marked down as the enable for U42, which I was trying to verify here. That was the serial port that I temporarily disconnected. Huh. Oh, that's weird. I thought this was supposed to be a low value resistor, like maybe a 0 ohm. And this seems to be open circuit now. Did I mess this up? Or did I not even test this? Did I assume this was good? I wonder if this is the root cause. That is 0 ohms. That's overload. And then is this U42 enable? I don't remember which one of these was enable. Okay, that's enable. Oh wait, now I'm seeing a good connection. Was I just not getting a good connection before? What? So yeah, that's R382 left side, which I think is also R382 right side. I think this is a 0 ohm link. Not the same as that. Was I getting this confused with 384? That would do it. No, now it looks like they are actually. Like, I thought that 384 was a pull down and 382 is a 0 ohm link. I've seen the same design feature elsewhere on the board. And I thought I already measured 384 as a 10K. Maybe this is just intermittent connection? Is it possible this is not a resistor, but is a diode? Okay, that's 100K in circuit. Gosh, what is going on with this resistor? I mean, maybe this is a high value resistor and the measurement is weird because this is in circuit. Or maybe it is a 0 ohm link and it's just got cold solder joints. That would explain some of what I've been seeing if this resistor or something nearby it was bad. Just curious in measuring the resistance between these and ground in circuit, the switch pins. This one's 21K, the other one is 100K. Okay, so this is between my soldered down wire and R382. It's 0 ohms on the right side. And now I'm reading 330K on the left side. Which would be a weird value for them to intentionally use here. I doubt that's actually real. Let's just reflow both sides of that resistor and see if this behaves less weirdly afterwards. Right? Like, I keep saying we haven't ruled out hardware problems. A lot of this smells extremely like a failed firmware update, but it could just be a really, really unlucky hardware failure. It's hard to tell. Alright, didn't even have to add more solder. There was already plenty of solder and flux in the area. I want to know what that part is. Like a high value resistor there would make sense if this was an input, but then why is the firmware writing to this as if it's an output? I mean, it could be both, but like this doesn't make a ton of sense. might take off that resistor and just measure it out of circuit. This is really suspicious. Can I get that off with this soldering tip? I mean, it's nice of them to label this R, because otherwise I would maybe start to wonder if this is actually a diode or something. It's not a good way to get a resistor off. Probably have to switch tools. Yeah. Yeah, I don't know what value that would be. I'm guessing, I mean, the thing that makes sense to me right now is that it's a broken 0 ohm resistor, but I don't know. That still doesn't make a ton of sense. Rectifier. Yeah. Maybe it's a memristor. Someone in Twitch is like, I just got here, but that's a resistor. I'm like, good job. Yes, I mean, that's what I would have thought too, but... Every resistor is also a capacitor and an inductor. There's just a question of how good of a resistor is it versus, you know, what it's doing in all those other domains. I don't know how any of you can really be sure of what that little anonymous two-legged surface mount part is, though, right? I mean, like, yeah, I mean, if it's like a little chip of, like, printed ceramic, it's probably a resistor, and if it looks like a multi-layer baked ceramic, it's probably a capacitor, and if it's a plastic package, it's probably tantalum, but, you know, I don't really know. It's all just pattern matching, unless you actually test the part. What are you trying to be, little part? Besides in need of a bath. I like R for resonator. Or yeah, R for broken. I mean, this totally could have been something that I messed up. I was soldering nearby this, but I wouldn't have really expected. I mean, I don't think it's that easy to break a 0 ohm resistor, but here we are. I think that's clean enough to measure. I think it's trying to be a 0 ohm resistor. I think it was just having trouble. I don't think I've got a solder bridge, and that's about 0 ohms across it. It's just probably got a crack in it on near one of the terminations. There's the other side, nothing on this side. Oops. Now it's conductive debris. Where'd it go? There it is. Well, let's try just replacing this with a solder bridge. I think that's what it was trying to do. It makes sense for that to be a combination of a 0 ohm and a 100K. And that's consistent with what I've seen elsewhere in the design. That makes sense because that would allow them to isolate those for debugging if they needed to. That resistor provided the random seed, right? My little clip keeps coming off of the plus 12 rail. Should maybe solder a wire on there. But instead I'm just going to bend the clip. Ooh. So, previously, before I knew that resistor was bad or had a cold solder joint or whatever caused this, it wasn't just a cold solder joint though, because testing the resistor itself, it seemed like a crack in the resistor. So that's certainly something I could have caused while poking around in here, but it also could account for maybe the original symptoms too. So let's keep that in mind. Yay. So there's a possibility that we just turn this thing on and it boots normally. I doubt it's that much of a possibility, but it's there. So we should try that. I'm also just going to... oh, actually, let's measure those resistances again. Because previously I was getting 100K and 30K. I'm wondering if maybe now I get 30K and 30K. No, it's still about the same. I mean, that's probably fine. The DC-DC input was probably just high impedance. Okay, well, we could just try powering it. One thing I might do while I'm in this poking around with the multimeter mode is to try to figure out where that other switch goes. So I'm also going to write down that IO 3.7, or sorry, 1.7, pin 38, that switches U42. Let's see. We can also probably skip any DC-DCs that are always on. So like this one right over here, I think that's 5 volts, which is always available. A couple of MOSFETs over here, which I might also be able to ignore. There's another DC-DC way over here under the heatsink. There's a couple more under the heatsink, actually. I don't know that I feel like taking off the heatsink right now before doing more debugging. If it does power on, I want the heatsink. Yeah, there's another power supply under where the power inlet is. I haven't tested whether that one's on or not yet. Okay, let's try turning it on. Are we good? Are we good? I think we can power this on safely. I think I can unhook all the Raspberry Pi stuff because I don't really need that right now. The serial port on the micro is still disconnected from the system on chip. We could connect that if that's necessary, but I'm going to leave it disconnected for now. Okay, so let's power up the emulated lithium battery. 3.7 volts. All right, and then 12 volts. Same as before, 60 milliamps. Let's just quickly look at a couple of voltages. Okay, and both of those DC-DCs are disabled, it looks like, or at least these pins are low, which I think means disable. Okay. So I think the next step is let's hold the MSP430 and reset by moving this jumper over here. So now the MSP430 can't boot, and I'm going to try pulling some of these lines up with the 3.3 volt resistor on a jumper, or with a 1K resistor connected to a 3.3 volt source on a jumper. 3.0 volts. That's interesting. Okay, now I'm going to be turning on one DC-DC and then the other looking at the current. So I'm going to start with U42, which we've already looked at. Oh, wow. That behavior is different. It's drawing half an amp and the front panel LEDs are on when I do that. So I don't know what that second pin is, but the original firmware would tend to turn both of those on at the same time. You know, I wonder if this is both bad solder joints and a bad firmware update, like maybe one caused the other. Maybe there were some bad solder joints near the MSP430 which caused the update to fail. What if I turn the other one on? Turning the other one on does seem to add 10 milliamps. I don't see any LEDs or anything. Well, that's cool. So we might have an on-off switch, maybe. Let's look at the serial ports on the O-scope. Coffee. I poured it and then forgot to drink it. The best coffee is the coffee that you don't forget to drink. Cold coffee means productivity. I don't know about that. I feel like I'm more productive when I know how to balance my attention between coffee temperature and everything else. Let's first take a look at the 3.3 volt power that is on the same header as the serial port over here. Okay, so 12 volts is still on. This is, I think, the 3.3 volt power supply that the system on chip uses. That looks right. So yeah, I think U42 is the 3v3, or at least something that leads to the 3v3 on the system on chip being available. And the other power switch, no effect from the other power switch. Okay, that's cool. Let's move to the next pin. Looks idle. I feel like maybe I should be doing this with the flash drive unplugged. I'm not extremely worried about it corrupting the flash drive because I have an image of it. So I'm not going to worry about that right now. Nothing here. The current settles at like 290 milliamps on the 12 volts with some front lights on. I mean, y'all can speculate about what these load switches do without knowing what the power tree is, but my big hints about what does what, other than the connectivity on the board, would be like looking at the context in the code. So my hint for this pin, the unknown one here, is that it's something that is switched at the same time as the system on chip, but without really any kind of you know, extra consideration for like delay or anything like that, and I don't see it being switched separately. So my guess is that it might just be a load switch that comes immediately after the 3v3 regulator, or it might be like a separate standby 3v3 circuit. Yeah, I don't know. I'm not really finding it useful to speculate wildly about that right now. I want to leave that heatsink on, but maybe solder on another header or three. Maybe I'll just hold the probe. So I think that first one was an idle serial port. I think this is the same pin, pin 2 on the next port, so this might be a different serial port. Probably also not running. Okay. It also seems very likely that the MSP430 generates a reset signal for the SoC, so it seems likely that we would maybe need to figure out what that is and like actually send, you know, take the chip out of reset once the power is available. Maybe a lot of other signs we could take to see how far the CPU is getting at this point, but this might be a good time to know more about when this function is invoked and like what else the machine has to do to turn on the power besides just turning on the DC-DC. Oh, I could try plugging in the backplane. I don't expect that would help, but why not? I put the metal part back on the backplane. I don't think that's extremely in the way. I mean, it's kind of in the way of my debug header, but I'm not using that right now. I'm going to plug in the fan because I'm a little suspicious that the backplane actually senses the fan RPM by looking at the current. There's info in the firmware about fan RPM sensing, but this is a 2-wire fan, so either that just doesn't apply to this model of the hardware, or they're doing something fancy. And I'm not ruling out the possibility that they're doing something fancy, because there is an analog comparator chip right next to the power for the fan. So they would have the pieces they need to sense current pulses, maybe. Alright, so that's just plugged in normally. Power up the lithium cell. Power up the 12 volts. That's interesting. The 12 volts was reading 0 instead of 60 milliamps. I do have the MSP430 held in reset right now. Let's try turning it off and then powering it up again without that. So now the MSP430 should be normal. Still 0. Shouldn't usually draw 0. It's probably something wrong. I'm not getting voltage here. I think I might have just put pressure on that clip just wrong as I put this in. Oh. Okay, I turned it on and panicked and turned it off because the current went up right away, but I think that might have actually been trying to do something. Let's do that again. So this is kind of what we were seeing before. I think most of that current is just the fan, and it occasionally tries to charge the lithium battery. But I think this is the same behavior we were seeing before. We can try to push the power switch. And do we see the same blink pattern? Yeah, so it's still in the reboot loop. Yeah, I mean, it would be kind of cool if we can get this chip into some kind of bootloader where we can, like, even if it's been wiped, even if we can just get the blank chip, get it into a bootloader, like program the binary we have on there, and then just start like jumping into functions. That kind of thing might be useful. But mostly just to keep us from having to solder as many wires, I guess. Anyway, let's see what happens if, when it's in this state, with the backplane and the fan attached, and I guess without that chip held in reset. Let's see what happens if I just try to apply power, or try to turn on the first DC-DC. So I'm using 3.3 volts through a 1K series resistor to just hit the enable pin on one of the DC-DCs. And while I do that, let's look at the serial port again. I think this is going to be the interesting pin, this one right here. Glue on there is very slightly in the way. I might have to go in on this side. Wow. So the lights on the... Oh, you can't quite see that on the camera. All the lights on the backplane turned on when I hit that power supply. Not a very clean power on, right? But I don't think the processor's actually trying to boot just yet. Oh yeah, and that's also a great place to look. Zoe is looking at the power sequencing docs from the system on chip. Yeah, that seems useful too. It'd be nice if we could find... So I was actually expecting to see power sequencing in the firmware, and so far it didn't necessarily look like the code I've been looking at is actually doing any sequencing. It's just the low-level kind of on-off primitive for one of the converters. But yeah, looking back at there and looking for some sequencing does seem like it would be useful. That's one of the things that I've been planning to do. Okay, gotta remember not to pay too much attention to chat. Well, that backplane is slightly in the way, but it's also kind of useful, so I guess I'll keep it attached. I swear the power supply isn't actually that pink. I think the green on the screen is kind of throwing off the white balance. It's kind of fun, though. So yeah, part of what was making this annoying to analyze is that it's pretty much all position-independent code. So I'm not going to find direct references to this. I'm going to find somebody calling it by adding a value to the program counter, which is just really frustrating unless you have some software support for decoding that. don't know if this is going to support position independent code either. Maybe we get lucky, but I suspect if we actually want to disassemble this, we end up having to write some code to handle position independent MSP430. You would not want to have the entire application in position-independent code. As the MSP430 instruction said, has no direct support and it would be very inefficient. Well, I think that's how this application is set up, though. Most of this seems to be position-independent. Maybe the bootloader isn't, but the application code sure seems to be. It seems like a simple enough app, though, that I don't know that it would matter. It would almost be easier just to do this without IDA and just write some kind of little single purpose tool just to do this. So like all of these are position independent jumps. Like this whole thing that it thinks is one big function is probably a bunch of different functions with tail calls. Yeah, so I've got one of these on the way, which will help, but maybe there's a way to do this with OpenOCD in the meantime. Spy by wire. if I have anything handy that we can reprogram that uses an MSP430. Yeah, I mean, I could probably find something with an MSP430, but that would involve me just rummaging around for a long time, which doesn't make a really good stream. So I'll think about that at some other point, but that's not really what I want to do right now. I actually have a TI CC tool, but not the MSP430 tool. I actually just want to know about the protocol, though. It's not SPI. It's SPI. This really seems like something that OpenOCD should know about. It's interesting that these pins on P4, well, at least pin 0 is set but not cleared. Though there's this big clear though. All right. So that's a switch. That's a switch. Oh, we know that P4.6 is the LED. Six is this. Oh, this is for blinking the LED. Oh, like this annotation is not really useful without having a way of linking together function calls, right? We can get a little bit of context just based on what's nearby, but it'd be really good if we could figure out where callers and callees are. This thing where there's a push PC and then add PC, that's a position independent function call. And this is just a mess. Yeah, I think we should continue with this, but I'm also kind of curious about that power sequencing. don't know if, for example, we would have a separate pin to turn on the core voltage versus the I/O voltage, but like I think we would want to find that sequencing, and that's not something we found yet. I think we want to find the caller for this function. What's up with TucoCam? It's weird. Video's coming through if I look at the actual monitor. There's like a hardware connection to the camera, and that looks fine. Is this a problem with video capture cards again? I think there's a problem I've had before where my capture card redefines some of the inputs as outputs spontaneously. It doesn't look like that. Yeah, all the Blackmagic cards on this machine died, like across applications. Excuse me. Oh, interesting. I restarted the other copy of OBS and that came back. It's maybe a user space problem with the driver, not a kernel space problem. I don't know if I can fix this without restarting OBS though. I could restart the stream, and then I have to paste these archive halves together. Well, that's fine. I hate technology most of the time. Oh, that's interesting. Is this one still working? No, it's just frozen. That's not working either. Alright, well, I don't know that I can fix this without restarting my stream. So, I guess I'll be right back. Sorry.